we want to start being able to use sine, cosine, tangent, secant, cosecant, and cotangent, our trigonometric ratios, in shapes or triangles that don't include a 90-degree angle. And so what we need to be able to do then is extend the definition of sine, cosine, and tangent so that they would apply to other things besides right triangles. However, when we do that, we can't change them so that they don't mean the same thing in a right triangle. In other words, we don't want to change the definition into something completely different. We just want to add a little bit to it so that if it's still a right triangle, it still means the same thing. But if it's not a right triangle, then the extra that's added on will tell us what to do in those cases. So I want us to think about these right triangles. All of these are right triangles. There's a right angle here, a right angle here, a right angle here. And so say we were interested in looking at a particular angle in that triangle. So I'm going to choose this angle, I'll choose this angle, I'll choose that angle. In this first triangle, if that's the angle we're looking at, then this side would be the opposite, this would be the adjacent, and this would be the hypotenuse. In this triangle over here, okay, so that makes this the opposite, this the adjacent, and this the hypotenuse. Over here we've got, that's the adjacent, this is the opposite, and this is the hypotenuse. What I want us to be able to think about is taking each of these triangles and turning them if that's what we need to do, flipping them over if that's what we need to do, so that the opposite and adjacent that make a 90-degree angle, the adjacent is a horizontal line and the opposite is a vertical line. Let me write that down. I'm just going to turn the paper, turn the triangle so that the adjacent is horizontal, and since the adjacent and opposite always are going to make a 90-degree, if it's a right triangle, the opposite must be a vertical line. So this first triangle here, we can see the adjacent already is horizontal, the opposite already is vertical. That one's set. That one's good to go. This big one over here on the right, we can see that in order to do that, we need to rotate it like so. And once we rotate it like that, remember that this was the angle we were looking at. This angle here is our 90-degree angle. Then our adjacent, and our opposite and our hypotenuse fall into place. This middle triangle, in order to do this, if we turn it, if we rotate it clockwise, we get, remember which angle we were focusing on. This is where we started. So that angle that's marked will come around down to there. And so the adjacent is now here. So here's the angle. And the adjacent is now here, the opposite's now there, the hypotenuse is now there. Maybe we'll just rewrite those. The adjacent is here, opposite here, hypotenuse is there. So I want us to always think about turning a triangle into this position where adjacent is horizontal, opposite is vertical. If we need to rotate or flip over the triangle to do that, then that's what we do. Now, imagine taking that triangle. So I'm going to take this one right here, and I'm going to copy it, and I'm going to paste it onto a graph. There it is. And we've got it in the position where the adjacent is horizontal and opposite is vertical. We'll just take that and we'll put it so the angle that we were interested in, remember that was this angle here, that angle is sitting right at the origin, and the adjacent lies right on the x-axis. Alright, so the opposite, the adjacent is on the x-axis. The opposite is going up and down in the y direction, and the hypotenuse goes off at some angle. Here's our angle. Well, think about the coordinates of this point up here at the other angle of the triangle. It's got some coordinates, x and y. How do the numbers that x and y equal relate to sides of this triangle? Remember that x just means how far over we have come from the y-axis, how far left or right we have come. That's what the x number is. But hey, that's the same as whatever this adjacent is. So adjacent is just x. It's how far we come along the x-axis. We turned the triangle so that that was the adjacent. What does the y-coordinate of that point mean? It means how far above the y-axis we have come, or below. For the triangle we've got, it's going straight up and down, so it's vertical. That's our y, that's our opposite. The opposite side is the same as the y-coordinate of this point up here. And the hypotenuse is the distance from the origin to that point. We're going to call that r for radius, because if we thought about a circle that went through that point, a big circle that went through that point, centered at the origin, that hypotenuse would be the radius. So adjacent becomes x, opposite becomes y, hypotenuse becomes r. That lets us change sine, cosine, and tangent. Sine of our angle we were calling opposite over hypotenuse. That's y divided by r. The cosine of our angle is adjacent divided by hypotenuse. But adjacent is x, and the hypotenuse is r. X divided by r. Tangent is opposite over adjacent. That's y over x. These three new definitions of sine, cosine, and tangent let us use this in triangles that don't have a 90-degree angle anymore. Because what we can do is we can say, if I wanted to, instead of thinking about this triangle here, think about a triangle that goes like this. It comes from, oops, let's make that nice and thick so we can see it easily. It comes across here, and it comes off like that, and it comes over here. If we're talking about the angle inside here, I don't even need this line. I'm just thinking about the angle between this line that's along the positive x-axis and this line that I went off at some angle. That angle's bigger than 90 degrees. I couldn't put that in a right triangle. And yet, there's our angle. And yet, we can still talk about the sine, cosine, and tangent of that angle, even though there's no way to fit it inside a right triangle. Because up here at the tip of our line, up here, there are some coordinates, x and y. Then the sine of whatever this angle is going to be the y-coordinate divided by this distance r. R is the distance from the point to the origin. Y divided by r is the sine of theta. Cosine of theta is the x-coordinate of that point divided by r, the distance that that point is away from the origin. And tangent is y divided by x. Those three new definitions will still work even for right triangles, but let us go to angles bigger than 90 that won't fit inside a right triangle.